Okay, so we're going to talk about rational functions. And a rational function is a polynomial divided by a polynomial. So rational functions remember that polynomials have exponents that are non-negative integers. So this would be an example of a polynomial, but this would not be, because that's a fractional exponent. So polynomial and not. Okay, so also recall functions. You have to be able, in order to have a function, you have to use all of the values in the domain. So when I look here at this one, if I look at the denominator, I get x plus 2 in the denominator, and there are conditions where the denominator would be equal to 0. And that would happen when x equals minus 2. So if x equals minus 2, I get, it's supposed to be a minus 2, minus 10 plus 10 over minus 2 plus 2, and what I get is 0 over 0. So 0 in the denominator is not allowed, because what I get is not a number. So I want to avoid this. So in order to keep that from happening, I say x can't be 2, or x can't be negative 2. So my domain here is everything except negative 2. And if I write this as an interval, which is what my math lab will often want you to do, well, so in the homework, I'll take that back. In the homework, it asks you to put the numbers that make the denominator 0. So that would be negative 2. Now, the next thing that we want to do when we often want to do when we're dealing with rational functions is to simplify it. So as I look at the top, I see that a 5 can factor out of the 5 and the 10. So I factor out a 5 from the first term, that's going to leave an x, and from the second term, that's going to leave a 2. And so those cancel, leaving 5. But even though I've canceled this, I have to look at the original. So in the original function, negative 2 is not allowed. So even though my function reduces to a constant, I still cannot use x equals negative 2. Okay? So if I can't use it in the original, I can't use it later. Okay, here's another one. So we have to recall, so we want to look for the values, the x values that make the denominator 0. So we start by factoring the denominator. And this is a difference of squares, so I get x plus 3 times x minus 3. It doesn't matter what order I write them in. So if I choose x equals positive 3, when I put that 3 in there, I'm going to get 0 times 6, which is 0. So if x equals 3, I divide by 0. Over here, if I put in x equals minus 3, I'm going to get, and that will become a minus 3, I'll get minus 6 times 0, which is 0. So I don't want that to happen. So x can't be 3 and x can't be negative 3. So when it says what values make the denominator 0, it would be 3 and minus 3. So in our domain, we want to let that not happen. So we keep that from happening. Okay, so I can't let x equal 3 or minus 3. And now I want to simplify my rational function. So I'm going to factor. So I had 2x squared plus 5x minus 3 over x squared minus 9. Now we had already factored the denominator because it was the difference of squares. Now I need to factor the numerator. And so 2 is prime. It's going to factor into 2x in the first set, the parentheses, and x in the second. And now I have this 3. So 3 is prime. It's either going to go here or it's going to go here. And I'm going to put it here with a plus because the signs are going to be different. And the larger one is going to be positive. So if I arrange it like this, I will get my 2x squared plus 6x minus 1x minus 3. So that's the correct factorization. And what we see when we simplify it, we have an x plus 3 on the top and an x plus 3 on the bottom. Now these are factors because it's multiplication. If it's addition, it doesn't work like that. But when it's multiplication, it does. We just cross it off. So this is my simplified rational expression. X still cannot be 3 or minus 3, but this is my simplified rational function. Okay, here's another one. So we start off by finding out what values make the denominator 0. So I can factor out an x, and I get x squared plus 1. Now the only problem I have is when x equals 0. Over here, when I look at x squared plus 1, the smallest number x squared can be a 0. And so if I take 0 plus 1, this is greater than 0 all of the time. For every choice of x squared plus 1 is greater than 0. So this does not contribute to any 0 denominators. So we get 1, and that's x equals 0, and x cannot be 0 because we can't divide by 0. It's kind of repetitive there, isn't it? Okay, so now I want to simplify it. So up here, I can factor out an x. So that's going to leave me with 3x minus 4. Down here, I can pull out an x. I already factored it, so x times x squared plus 1. And those x's cross off. This is the simplified expression, but x can still not equal 0. Because we go back to the original function to look at that. Here, this is the same situation that we had earlier. X squared is always 0 or larger, so x squared plus 4 is always greater than 0. In fact, it's always greater than or equal to 4, which is greater than 0. So this one, I can use all real numbers because I'm not going to divide by 0. It doesn't factor, so this doesn't simplify. All right, same thing here. I look at the denominator. It's a difference of squares. So I get x plus 1 and x minus 1. So x cannot be 1 or minus 1, because if x is 1, I divide by 0. If x is negative 1, I divide by 0. So x can't be 1 or minus 1. All right, now I'm going to see if this factors. The signs are the same, and they're going to be negative. Remember, when this is positive, when the second sign is positive, the signs in here are the same. And then we look at the sign that comes here, the middle one, to see whether if they're both positive or both negative. Since it's negative, they're both negative. And there's only 2 only has 2 factors, 2 and 1. So it has to factor like this. Okay, and we already factored x squared minus 1 because it is a difference of squares. Factors like that, and we see we have a common factor here. So we cross that off. There's our simplified rational function, and x cannot be 1 or minus 1. This is a really important topic when in calculus, this idea of being able to simplify rational functions while understanding that the original, the functions that you cannot use in the original can still not be used in the simplified version. Okay, so we look here, x squared plus x minus 2. So we get x and x. The signs are going to be different, so one's going to be positive and one's going to be negative. That's positive, so the larger one's going to be positive. And 2 only factors into 2 and 1. So that means the 2, since it's larger, is going to go with the plus, and the 1, since it's smaller, goes with the negative. This number, or this, not number, this polynomial up here is a difference of cubes. So looking at your formula sheet, we get the following factorization. And I messed up when I made the problem, so the things that I thought were going to cancel, they don't cancel. So this is simplified as much as it can simplify. And now I need to find the 0 denominators. So x cannot be equal to negative 2, and x cannot be 1. If I pick 1, that will be 0, making the whole denominator 0. If I pick negative 2, this one will be 0 times whatever's there. All right, now we have adding rational expressions. So this is a fraction with some variables, and so it works just like it does with the numbers. We need a common denominator, and so the easiest thing to do is just take this up to the other side and then add across. So what happens is I'm going to get 2 times x minus 4 over x plus 3 times x plus minus 4. So multiply by x minus 4 over x minus 4. Repeat here, multiply x times x plus 3 over x plus 3 times x minus 4. Okay, I have a common denominator, which is the x plus 3 times x minus 4. Now, I'm going to distribute here, so I get 2x minus 8 And now that we have a common denominator, we just add across the top. X squared plus 3x, right? Let me check that one more time. Okay. And so that all goes over our common denominator, and I can combine like terms now. 3x plus 2x is 5x. And I don't know that you have to expand this. You may have to. So if you do, that'll give you x squared minus 4x plus 3x is minus x minus 12. And so that would be your expression. X can be neither -3 nor +4, because that would make the denominator 0. That's how it works when we want to add rational functions. Here's another one. Now if I factor this like I've done earlier, x squared minus 1 factors into x minus 1 times x plus 1. Now I need to get a common denominator. I already have x minus 1, so what I need is an x plus 1. So I do that in the top and the bottom, but only to this one. And so I get x plus 2 minus 2 times x plus 1 over x squared minus 1. And so I get x minus 2x, and then 2 minus 2 is 0. And we get that. X cannot be 1 or minus 1, because that would make the denominator 0. Okay, so here we have rational functions that are multiplied. So just like with numbers, we multiply across the top and we multiply across the bottom. If you have to simplify, that would be x squared plus 3x plus 2x is 5x plus 6. And that would be it. X can't equal, now look up here, x can't be minus 2 because that would give me 0 here, and x cannot be -3 because that would give me 0 in that term. Alright, so multiply across the top and multiply across the bottom, but before I do that, or maybe as I do it, if I factor x squared minus 4, that's going to give me x plus 2 times x minus 2, and then I have this. So that's going to give me nothing that I really need. I'm not going to factor this, even though it's a perfect cube. I could, but it's not going to give us any factors that are going to cancel out, so it's not necessary. So the x plus 2's cancel out, and I get 2x plus 3 over x squared, x cubed minus 1. Now it's possible that I need to go ahead and expand this. So, looking back, that's going to be x times x cubed minus x times 1. Whoops, wrong way. Okay, that's going to give me minus 2x cubed plus 2. And I can also write it in standard form in the denominator. So x to the 4th minus 2x cubed minus x plus 2. Alright, and so that would be, we would go back to the original. X can't be 2 or minus 2 or positive 1, because 1 cubed would be 1 and 1 minus 1 is 0. Alright, now here we have a rational function divided by a rational function. So just like in fractions with numbers, we take the top times the reciprocal of the bottom. That does factor, but it's not going to factor into anything that's going to help us simplify the expression. So now that I've flipped it and turned it into a multiplication problem, I'm going to distribute here. So that's going to give me 5x squared plus 15x minus 20. And then on the bottom, we multiply, so it's going to give me 7x squared plus x. X can't be 0, because I would divide by 0 there. This can't be 0, because that would make this whole fraction 0. So x cannot be minus 1/7. And finally, this cannot be 0, because then we would divide the denominator fraction by 0. So x squared plus 3x minus 4 equals x plus 4 times x minus 1. And so x can't be minus 4, because that would make that 0, wiping everything out, and x cannot be minus 1. Not minus 1, positive 1. So x cannot be minus 4 or 1. So x can't be 0, it can't be negative 1/7, it can't be negative 4, and it can't be 1. Alright, and that's what I had for this recording.